Okay, so we have a golf ball. The initial velocity is 0. Okay, so for this ball, V initial is 0. And then the golf club comes along. So like, look, here's your golf tee. Here's the little golf tee like this. And then here's the ball, right? So the initial velocity is 0. We're given V final as 2 times 10 to the 2 feet per second. That's 200 feet per second. You got to convert that to meters per second. So the way you do that, I went like this. 1 foot is 12 inches. So then feet cancel. And then 1 inch is 2.54 centimeters. I'd give you those conversions. And then there's 100 centimeters in 1 meter. So then the centimeters cancel. And then you're left with meters per second. Okay, so when you punch that all in to your calculator, let's see. The 200 feet per second, it's equivalent to 121.92 meter per second. Now, over what time period does that velocity change occur? They give it to us right here. The club is in contact with the ball. I mean, talk about a split second. 0.002 seconds. I mean, that club just goes bam, the ball's off the club, fraction of a second. What else do we have? Mass of the ball. You want to make sure that's in what? Kilograms. 55 grams, 0.055 kilograms. Okay. All right, assuming that the ball has a mass of 55 grams, find the average force exerted by the club on the ball. So the club comes in, the force of the club is like that, right? Club. The force of the club comes in, bam, strikes the ball. How do we find the force of the club? Well, let me show you how to do this with momentum. This chapter is on momentum, and then I'll show you how you could have done this 2 months ago just with forces. All right, so with momentum, one of the equations you learned is F net equals change of momentum over time. That was Newton's original second law. Remember, did Newton say F net equals ma? What did Newton say? Change of momentum over time equals F net. Now, what can we say for change of momentum? Well, change of momentum is going to be momentum final. Remember, what's momentum? Momentum is mv. So what would momentum final be? mvf minus momentum initial. What would momentum initial be? mv initial. This is momentum final. That's momentum initial over the time. Okay, what's the initial velocity of the ball? 0, so that part goes away. This part crosses out. So now what we have is net force equals mvf over time. And we have everything. 0.055. V final is 121.92 meter per second. And then the time is 0.002 seconds. So this gives us a net force of 3,352 newtons. Oh, and by the way, is the net force the force of the club? Is there any other force causing the acceleration? So the net force is the force of the club, because it says right here, find the average force exerted by the club on the ball. So the force of the club is 3,352. Okay, real quick, how could you have done this with forces? So before I erase this, any questions? Yo. Okay, let me help you with that. I'll show you on the. You might be punching into the calculator wrong. Let me finish this and I'll help you. Okay, solving this with forces. Look, here's the ball. Shh, check it out. Oh, force of the club. It's like that. So look, if you sum the forces in the x direction, force of the club, hey, what does force always equal? What does net force equal? MA. So we could find the force of the club this way. Now we just got to find the acceleration. Do we have enough to find the acceleration of the ball? Yeah. You go like this. You go VF equals V initial plus AT. V initial is 0. So A is going to be VF over T, which is 121.92 divided by 0.002 seconds. So whatever this comes out as, plug it in there for A. You got your M. That'll give you the exact same answer, 3,352.